One thing I should note on here as you're getting started, for like 5 here, that's in degrees, so I want that the degrees of that arc. Here though, this is in centimeters, so I want the length of that arc, not just the degrees. Okay, there's a lot going on in this problem, and as we talked about yesterday, the hardest part is looking at the problem and separating out what you need to know for each piece and what you don't need to know. So let's look here. We're finding GF. GF goes all the way across. GF, in other words, is just the diameter. Yeah, we're given OG is 3. GF is going to be 6 centimeters. Now, angle EDA, so that starts at E, goes to D, and then up to A. That angle, we need to know some arcs. Well, let's label what we know here. I'm going to put them in red. ACF. ACF, that this angle here is 30 degrees. We know angle DA from here to here is 70 degrees. So that's an arc DA. Arc GE from here to here is 120 degrees. That's it for angles for now. So we want to know angle ADE or EDA. Well, we would need to know the arc from here all the way around to here. We already have the 120, so if we just had this piece up here, we could add them together. Then, of course, we know that angle EDA would be half that because it's an inscribed angle. So is there a way to figure out arc AG or angle AOG based on what we have here? And there is, because we know this is a right angle and this is a right angle. Because those are tangents, the radius always makes a right angle to tangents. That is a 4-sided figure then formed here. What is the angle sum of a 4-sided figure? 360, yes. N minus 2 times 180. Well, 4 minus 2 is 2 times 180 is 360. We have 90 and 90 is 180 plus 30 is 210. This angle in here is 150 degrees. If we know that angle is 150, this angle has to be 30 because that makes a straight line. So that makes this arc here 30 degrees, which makes the big arc in green, 30 plus 120 is 150 degrees, which makes angle EDA half of 150, or 75 degrees. See how easy that was? Do you want me to go back over that? I mean, did you follow what I did, or yeah? Okay. The 150 is the arc from here all the way around to here. And since this is an inscribed angle on that arc, it's half of the arc. Remember, if the vertex is at the center, the angle equals the arc. If the vertex is on the circle, the angle equals half the arc. Now we want angle EHF. EHF is this angle right here. Well, we know this arc up here, 70 and 30 is 100 degrees, correct? If I knew this arc, we could find that angle. Well, how do I know that arc? Well, this across here is the diameter, right? GF. So this has to be a 180 degree arc all the way around here. That's 120. This is 60. So now this angle, remember, if we have two chords that intersect inside the circle, The angle is the sum of the arcs divided by 2. It's the average of the arcs. I've got a 100-degree arc on this side, a 60-degree arc on this side. I add them together and divide by 2. That's 80 degrees. So this angle right here, I'm going to label it on this side, is 80 degrees. The circumference of the circle, there we go, 18.84 centimeters. That's just going to be that diameter that we found, 6 centimeters times pi. Arc ADF in degrees. ADF is the arc that starts here and goes to here, right? Well, this is the diameter still, and we know that this is 30 degrees, so that arc has to be 180 minus 30, or 150 degrees. Also, we know the central angle is 150 degrees, so that arc off that central angle is 150 degrees. Once we start to learn more and more here, then when each piece, there's probably 2 or 3 different ways of finding it from the information we have. Well, as we have more and more pieces filled in here. So arc EF, that's this one from here to here. We want that in centimeters. Well, that's 60 degrees. So we know that's 63/60ths of the circumference, right? Times the 18. So that makes that 3.14, right? Centimeters. Just pi, because the circumference was 6 pi. Area of sector GOA. That would be this sector right here. It is a 30-degree sector. To find its area, we need the area of the whole circle, which is going to be pi times 3 squared. 3.14 times 3 squared. Oops. 2826, yep. Centimeters squared. And then times 30 over 360 is going to give us what? 2.35 about, 36 centimeters squared. Yeah, so 2.36 around it. Centimeters squared. Angle OFC. OFC, this is an easy one. This is a give me. Here's angle OFC. What's that have to be? 90 degrees, because it's a radius to a tangent. The length, KJ. K to J has to be what? Well, E to K is listed as 2.5, right? Nope, 2.5. So JK has to also be 2.5. Because since that diameter is also a radius, it contains a radius, since that hits at a right angle, it has to cut it in half. Angle ABD. ABD, that's this angle right here. Well, that angle cuts an arc here of 70 degrees and an arc over here of 150 degrees. Remember, an exterior angle, it's the difference of the arcs divided by 2. Exactly. The interior angle, we added the arcs together and divided by 2. Exterior, we subtract them. So it's 150 minus 70 over 2. Yep. You got it. What do you think? Better than a sharp stick in the eye? So the big concepts to remember here long story, is if this arc from here to here is 30 degrees. What's this angle? 30 degrees. If this arc from here to here is 60 degrees, what's this angle? 30 degrees. This is a central angle, so the angle and the arc are equal. This is an inscribed angle, so the angle is half the arc. That tangent going through there, what is this angle? 90 degrees. Has to be a right angle to the radius. Now, one that did not occur in this problem so I have two tangents that come and intersect out here, right? If I give you that this length is 18 inches, what's that length? 18 inches. The two tangents have to be equal. The length of the tangents from the point of tangency to the point of intersection has to be the same. Now, this is one we calculated in the last problem, but we didn't necessarily state it as a rule. Those two tangents then that intersect out there, these have to be right angles because they're the radius to a tangent. If this angle here is, oh, let's call that 70 degrees. This angle in here will be 110 degrees. Why? Because a four-sided figure has 360 degrees, and we have 90 and 90, which is 180. In other words, these two angles will be supplements. If I have this arc here is 40 degrees, and this arc over here is 86 degrees, what's this angle? I add them together and divide by 2, right? So that give me 63. That's a 63 degree angle. This is 63 as well, yep. Try that again. How about this angle? That's 86 minus 40. You got it. You got her, 23 degrees. Tracked. Exactly.